Big custom Fowler flaps.
Brakes really now.
Drop over here, bud. This flight was also cut short. Briefs and the debriefs. Hello and welcome to the Hakan Lancair 320 Flight 2 video. If you'll remember, this is the Lancair 320 that's been modified with big Fowler type flaps. Hakan brought us in to take the airplane from the first flight through proving those Fowler flaps. But on flight 1, we were a little bit held up with a temperature problem. We had a cooling problem with the oil and the CHTs. Flight 2 is a quick flight, but I think there's some good data in there. Some interesting stuff for people. We've tried to keep with our... We've tried to keep with our previous technique of showing the briefs and the debriefs and trying to show all the technical stuff that we can. In the meantime, I'm taking an opportunity to thank our sponsors, Butler Parachute. Thank you for making the best parachute in the business. And thank you to all our new Patreon subscribers. It's been really nice to see the following of people supporting what we do. Check it out, and thanks for coming along.
Tower information X-ray, time 1853 Zulu, wind 310 at 8, visibility 10, sky clear, temperature 24, 2.16, altimeter 29 visual approach in use, landing and departing runway 27, hazardous weather information for the subject.
So right before the flight, we had an interesting conversation as we were sort of assigning duties and trying to figure out whether Hakan was going to ride in the chase aircraft or stay on the ground. It really came down to whether or not there'd be anybody on the ground to do the inside of the fence, outside of the fence duties that we consider critical, certainly more so on higher risk flights, but in general, it's sort of a part of the Wasabi thing. So real quick, what is inside of the fence, outside of the fence, and how does that pertain to this conversation? An aircraft wreck could end up in many different places, and Justin and I had a personal experience where a friend of ours crashed an airplane on an airport, and what ended up happening was that he was just barely beyond the airport perimeter. And so what happened was all the guys that had seen him crash jumped in their trucks and they took off across the runway and across the desert and out towards the wreck. But they reached the fence before they reached the airplane, and what makes a really awkward situation, right, where you need to drive all the way back to where you came from, basically, right, go back to the airport fence, drive around the airport, and then try to find some perimeter road or something that's going to get you to where the wreckage is. Meanwhile, your buddy's in a really tough state. So one of the services that Chase can provide, you can beat eyes in the air, pointing out where people need to go to direct emergency services. The most direct, of course, being the guys, some assigned person that's there to observe from the ground knows whether they need to back up and go to the fence or whether they can just go directly towards the wreckage. The next step is, when a fire truck shows up and you're trying to direct them, from the freeway or from the airport gate or wherever the 911 call directed them to where the actual wreckage is. And that requires a relay point, right? Somebody with a handheld radio in one ear and a cell phone in the other ear to talk to the 911 operator to tell them where to go, or to flag the guy down and use the radio to tell the fire truck where to go. And these things can shave valuable seconds or minutes if somebody's in a fire or bleeding out or trapped inside the airplane, and it's a part of what we do. In this case, this is not a first flight of the airplane. We've had some engine temperature issues, but there's nothing to make you think the engine's most likely going to melt down on one of these flights. So the question was, could Hakan's significant other, Oksana, could she take that role of doing the ground control job? And if she could, then we could put Hakan in chase, which allows us to have more eyes on what's going on. And also, since it's his airplane, we try to create an opportunity for the owner to put eyeballs on his airplane. So that's what this discussion was about. Brief mission overview. We're going to take off. We're going to climb up to the top of the airspace, and we're transition out of the airspace and go north. So staying under the airspace, under 4,000. We're going to go north, climb up to 7,500, cruise for 15 minutes with as much power as we can run and stay under 140 knots at level. Just try to put some time on the engine. And then power back RTB, come in and do a left-hand pattern to land on runway 27. You're going to start there. I'll start here. You're going to lead us out. We'll go to the non-movement line.
Start on button 1 so that we can get comm check done.
Okay, comm check on 1. And then we'll go over to ground. You'll make the calls for the flight down there. We'll both do our run-ups. Once we both get thumbs up, then you're going to take off, coordinate for the pickup. The pickup itself will be 2 calls before our brake release call, however that works. And I'd like to get a radio check in there once you're airborne. Take off, left turns. I'm going to get off the power as soon as possible, and we're planning to climb at 125. In the event that it's still not cooling, I'm confident we're going to just go out to 143, which is our limit for the day, VA. We're going to be quick to pull the power back, black knob back. First power reduction is just going to be the blue knob, so back from 27, or what was it last time, 2750, 2650, something like that. Back to 2500 RPM. For first power reduction, assuming temperature stay under control, we'll stay full black knob at 125 knots. If they don't stay under control, we're going to lower the nose out to 143 and start sawing the power off. In the event that we're not climbing or temps are still radically out of control, then we'll just RTB. The idea being to do that before we transition out of the airspace. Yep. So I want to make sure that we have temps under control before we deal with leaving the airspace, because then we got to come back here and deal with all the fire. Yep. Assuming that all goes well, it'll be transition out. We're going to go to button 1, fingers, go out to the north, climb up to 7,500, 15 minutes of making power. Well, not any power, but making some speed, let things get hot, and then RTB back in. You'll be making the calls to transition back into the airspace.
All day.
What's up?
All day.
Come back in, assuming left-hand pattern for runway 27 as well. Touchdown. I'll assume.
Actually, if you come in from the north, it's right.
We'll ask for
left,
okay. Just to make.
Just from the phone call was that you could expect left. But,
yeah.
But yes, whatever. For mission limits, we're going to use speed limit of 143, which is maneuvering speed. We have a stall speed calculated clean at 70 knots, so we're going to use 1.1 as our minimum speed, so 77 knots-ish. 77 being ish of 1.1. Yeah. But we'll use 77. With the flaps up, we're limited to 3.8 Gs. We're not going to go anywhere near that today, so we're going to stick around 2 Gs, something like that, just whatever it takes to maneuver. We're not planning to intentionally expand that. Gear speed extended 122 knots. And those are all the speeds that pertain. Any other limits? Oh, the temp stuff. So CHT limit for climb out would be 400 degrees.
You can go a little higher. 410 max.
410, okay. 410 degree CHTs on the climb out, and then for cruise 380. Oil temp I have 215. Okay. And then again, we talked about it, but it's full black knob, full blue knob for takeoff. First power reduction is blue knob back to 2500. Yep. And we'll stay full black knob, assuming everything stays nominal, all the way up to 7500. And then once we accelerate to 143, we'll pull the black knob as required to stay below 143. Okay, so that's the mission limits. We don't have a parachute, so we're not going to worry about bailout. Emergency procedures.
All right, and we want button 1 is 1, 2, 3, 4, 5. Clear 2 is up. And you're loud and clear, homie. Loud and clear, awesome.
So last part of any brief, I like to go over the emergency procedures for that particular flight. In this case, the 2 that we talked about were first, emergency gear extension. Every airplane is a little bit different. The 320 is slightly different than the Legacy, which I have a lot more experience in. So we went through that top to bottom.
And then you pull that, and then it should go down.
So the last one was a canopy emergency release. So the 320's canopy is a little bit interesting in that it has 4 canopy tie downs. So you have the 2 emergency latches, and then you have 2 more emergency pins. So the question is that, you know, in a hard landing, you can actually tweak the fuselage, and sometimes you wouldn't be able to get the canopy open. So if you're trapped in the airplane, it's on fire, bad news. So sometimes in some aircraft it makes sense to release the canopy before you come to a complete stop or even before you land. Like in the T6 we always land with the canopy open for this reason. So in this moment we're just trying to decide what's the right procedure for the airplane. So your point is, so boil that.
My point is I'd pull the, if the hooks will keep it, I'd pull the thing that has the highest probability of binding.
And the question is, will the hooks keep it? So you're saying the pins were always a safety mechanism and the hooks were the primary? Yeah. Okay. So if that's the case, then you pull the pins.
Yeah.
Pull the pins?
That's where I ended up.
Airborne? So downwind, I'm pulling the pins in a going to go off the runway, we're on fire situation.
Yeah.
As far as fighting with the EFIS, my plan is to... So on flight 1 we had an issue with the EFIS. So not only was the cylinder head running away, but we also had issues with the EFIS sending up alarms, unnecessary alarms that were pulling, it's a small display. So just any of those alarms actually pulls the display over and you have to toggle back to get CHT information, RPM information, whatever the problem you're trying to find. And because they were sort of nuisance alarm, they kept pulling it over, and it was sort of distracting, but also just made it difficult to get the information. So this is us working through a strategy for how we were going to deal with that for flight 2. When during the run-up, confirm that we have a strategy to get the EFIS under control.
Yes.
So I have the information that I need. If I have to sit there with a bunch of power on it for a while, because I need to run it up enough to get the fuel pressure alarm to go up, confirm I can clear it. So assuming I can do that, then we're going to go. If I can't come up with a workable solution, that's going to be a no-go, and we'll come back.
So I tightened the cylinder for the gear door a little bit, so it goes further vertically, if you will.
Yeah.
And also the small gear door that I had here, I removed that one for now.
Okay.
So we'll see if that
So this front gear door here.
Yeah, it's gone.
Exactly.
It's gone.
So it's going to be a gaping hole here, and if that works better or not, I don't know.
So Justin, worth noting, so with this door further in, these axle nuts, the one on the far side could catch. You can see, I think that's a mark from it maybe. So just something to think about if the door gets hung or the door hangs the nose gear. That'll be something you can help with eyes on.
Copy.
Yeah. I also put a heat shield here because it was a little, I wouldn't say burnt, but you could see that it was heat that came in there. So.
And you used silicon, that high-temp silicon stuff from 3M?
No, this is self-adhesive.
Oh, cool.
Next thing, the oil cooler. So I opened this up. There was a small NACA scoop here before that wasn't used. So I cut this out, put the new scoop in, 3-inch hose going into the new oil cooler, which has 8 rows instead of 6, so it's a larger one, and exits the same way through the exit of the cowling. So hopefully that should make some difference. This was plugged before as well, so I removed the plug, made a splitter adapter. So there's 1-inch hose that goes to the gasculator in here to cool that, and 1-inch hose that goes to the mechanical fuel pump.
And this was because we suspected high fuel temperatures on the
Exactly, vapor loss.
Because it was dieseling.
So,
It's idling weird.
It was idling weird, yeah.
Thumbs up. Roger. And flight push tower. Flight check. 2. We're on a tower. Glitter 1's correction. Glitter 2 is ready to go. We'll be left close traffic. Airborne pickup on Glitter 1.
Glitter flight, Ramona Tower, number 1 is cleared for takeoff. Left traffic.
Just a correction. It's going to be Glitter 2 on the left traffic, and Glitter 1 will be Airborne pickup.
Sure.
That'll be in Glitter 2, clear for takeoff, 27 left close traffic. Alright, ready to go. Alright. Trim set.
And Glitter flight 2 at your discretion, runway 27 cleared for takeoff.
And Ramona Tower, was that a call for Glitter 1?
From the dash 2, Glitter 1 at your discretion, runway 27 clear for takeoff when you're ready.
And Glitter 1's taking the runway now.
Glitter 2 is 10 left downwind, 27.
Left turns, oil 75, CHT 340.
Okay, so this is a good moment to talk about the airborne pickup. The airborne pickup comes down to basically how to get chase in position for as much of the flight as possible. These are the wrong airplanes. That'll work. Okay, so it's all about getting chase in position for as much of the flight as possible. So if this is the test aircraft, this is the chase aircraft. So you're really not adding value from a system safety standpoint unless you're close enough to be able to look for things like smoke and oil on the bottom of the airplane, which means you basically got to be in pretty close in what we would call sort of a slot position. The alternative to an airborne pickup is to say meet at altitude or do a standard rejoin. The problem with the standard rejoin is you need to do it high enough that you can sort of monkey around with doing rejoin stuff, high enough that if the test aircraft has a problem, they can still deal with it, right? You don't want to be sawing on the power at some medium altitude where the airplane can't safely make it back to the airport. So the safest thing to do is to have the chase be on board just as close to liftoff as possible. Let me draw this out. Okay, so it all comes down to positioning the chase aircraft underneath the test aircraft on that takeoff roll. So say we're sitting here on the runway. How do we get from there to somewhere further down the runway with the chase aircraft underneath? Which really comes down to acceleration. How fast does the test aircraft get up to flying speed, get airborne, get high enough off the ground so that the chase aircraft can get underneath? Because there's such variability, you really want to have what we would call sort of a turning approach, right? So like approaching a pits or something like that, you're sort of flying a constant radius turn as you come in to do that airborne pickup. So the chase aircraft ends up calling brake release of the test aircraft when he knows that he can get into position to do that airborne clean and dry check. The reason we do it as a turning approach is that if you say call it right there, you can, from that spot, right, you can cut the corner and fly direct to where the airplane's actually airborne. You can extend the turn, something longer here, right? Or even in an absolute worst case, you can actually go around to the opposite side and do the airborne pickup from the far side. So the reason we do a turning approach from the chase aircraft is to give as many options for the chase aircraft to fix whatever his brake call was, if it wasn't perfect, right? The next problem is that if the test aircraft doesn't hear the chase aircraft make the call or isn't ready to brake release just as soon as he calls for it, then there'll be more delay and it can also mess up that approach, right? So what we do is we have what's first a 30-second call, and then typically a 10-second call, and then a brake release call. At Wasabi, we've changed it a little bit. So here at the 30-second call, we add in a comm check, right? So when the chase aircraft calls 30 seconds, he's expecting the test aircraft to say something to acknowledge it on the radio so that we know that we've established good communications between the two aircraft. The 10-second call ends up being the get the airplane ready to fly standpoint, right? So from 30 seconds to 10 seconds, we're just holding while the chase aircraft gets positioned. And then at 10 seconds, we're going to start revving the engine up on the test aircraft so that just as soon as he calls brake release, we can as crisply as possible give him the acceleration that he's expecting so he can start to get into position. The problem is that if you're expecting to fly this little tiny pattern, right, so that you have that variability as far as your approaches, right, that we've just talked about, that's a pretty tight turn, right? So maybe it's a sort of in the order of like a minute turn or a 2-minute turn. It's relatively tight when you consider that most airports, we're gonna have a much wider pattern being flown by the traffic, right? So again, this is an issue that only really comes in on those airports where you're sharing the airspace with a bunch of other airplanes doing a bunch of other stuff, right? The problem is that the tower expects chase to be way out here on what would be considered sort of a normal downwind. The chase doesn't want to be there. He sort of wants to be sort of in this area, something much tighter to the airport, right? So how do you coordinate with all the traffic that's going on in the area? The big things you do is try to brief the tower before you fly. So in the case of this program at the Rona Airport, Justin makes a call or visits the tower face-to-face before every one of these flights to make sure they understand what is an airborne pickup so they have an idea of what to expect. So that tells the tower, hey, we're not going to be out here on downwind, right? We're going to be somewhere inside. Sometimes the response is, well, if that's the case, and this, what I've drawn here is a left-hand pattern, they'll take us and put us on the opposite side so that we're deconflicted automatically from what would be sort of training traffic that's out here on the outside. Of course, if you have the airport to yourself, it's an uncontrolled field, no one's around, you can kind of do whatever you want. But in the case of this takeoff, since it's at Ramona, it's a controlled airport. The alternative is our sort of towered airport approach, in which case the chase aircraft flies the full traffic pattern as expected by the tower. As he rolls onto final, he's cleared for the low approach. The test aircraft is cleared for takeoff. But instead of trying to make that pickup work where there's no geometry advantage, right? There's no way to cut that corner and change the geometry after you call brake release. We'll actually just spin it, right? So the chase aircraft will overfly the test aircraft and fly a much smaller 360, allowing him to make that sort of 30-second call, and 10-second call before actual brake release, right? Something like that. But it all comes down to the chase aircraft's ability to call the brake release such that he has the timing to do the pickup.
Little turbulence.
November 423, Juliet Whiskey, I'm on a tower. Into the right downwind runway 27, report beam tower.
30 seconds.
Traffic 27, report beam tower, absolutely.
Okay, so there's the 30-second call. You can see Justin trying to slip it in between the tower's normal calls so that we're not being disrupted, but at the same time the information's being transferred.
Got it.
And there's Tess confirming that he has good comms.
10 seconds.
And there's the 10-second call, so now the test aircraft will start to stand the power up, let the fuel pump spool up, let the prop governor spool up, get everything ready, so as soon as the brake's released, the airplane goes.
Brake release now.
Pretty fat, no leaning.
So with that last bit of power, you could see the engine started to run rough, so I pulled the red knob back to try to clean out the mixture, clean it up a little bit, and that worked.
I cleaned it up, airspeed alive. Got the fuel flow alarm.
Okay. Move to the left side. Correction, your right side.
First power reduction. CHT is just under 400. .400 CHT.
Copy.
Power's coming back. Keep the nose nice and low. 412. Give it some more gas.
So here shortly after takeoff, you can see the CHTs are starting to run away, so we're using mixture to try to cool things down.
Black smoke.
Say a lot of black smoke.
Just a couple puffs.
Copy.
How's your temp?
And with that richer mixture came black sooty exhaust, and he can see that, so he's giving that feedback to me, gives me more SA on what's going on.
415.
That's it.
Glitter 1's RTB. 416.
So before we get into a conversation about whether or not 410 degrees or 415 degrees is a reasonable CHT limit, I think it's important that we talk about the briefing that we had before the flight, right? That briefing where we go through the limits of the day, right, is sort of like establishing a contract between the owner and myself, right? If I was to decide that, yeah, we had talked about 410, but it's not going up that fast, and I push the CHT limit out, it gets really hard for me to defend the fact that I melted down the engine because I made decisions on the fly. In some situations where it's less congested airspace, right? Ramon is a pretty congested airport. Since Hakan was in the chase plane, he could call up on the radio and say, you know what, it's not going up that fast, let's proceed, or let's take that limit, push out to 430, sure, and I don't like changing CHT limits on the go, but because he's there, you might be able to do that. In this case, there really is no option, right? I, as a test pilot, have made an agreement with the owner that I'm going to not, at 410 degrees, we're going to knock it off for the day. We're at 415, the day's over. So we're going to RTB, and we're going to talk about this on the ground.
Copy, remote tower, Glitter 1 is going to be landing. We're current mid left downwind.
Clear flight 1, runway 27, clear to land.
Copy, Glitter 1 clear to land. On board for the gear.
There they go.
Clear flight, you guys declaring emergency?
Negative on the emergency. Airspeed 100 knots.
I'm showing 93. Go ahead and fly 110.
Working 110.
So another great example of great chase work. Here you can see Justin making the simple call of fly 110 rather than you're off by 10 and then me having to decide whether I need to fly 10 fast or 10 slow. That fly 110 is directive, allows me to know what to fly and move on to the next problem, which helps with the helmet fire going on in the test aircraft.
I got 3 green.
3 green from here.
Power's in idle.
Yeah.
Remote tower, Vision Jet 987, Mike Kilo 27, ready for departure.
2 feet. 1 foot. Couple inches. And set down.
We have brakes.
Vision Jet 987, Mike Kilo, remote tower, hold short, runway 27 at the hold short line, waiting release.
Just like we briefed, I made a full mixture for takeoff. Yep. And it was popping and pissed off. So I sawed off, previous flight, sorry, I thought you heard all this. Previous flight, I sawed off like 3 inches to get it to run right.
Yeah.
This flight I did like 2 inches.
Yeah.
And that seemed to be enough. But I think I saw 17 gallons per hour.
Did you push it back in when you turned left, Crossman?
Yeah, so when we decided we were hot,
Yep.
everything stood back up, and then you said, I see black smoke. And
Yeah, and it was like It was like puffs of it.
Yeah, I think it's really fat. But at that point, I would take it, right? Because I wanted the gas to go through the
Right. What kind of CHT did you have prior to takeoff?
340. I called that. Did you hear that? CHT 340.
Did you have any warnings on the ground?
No.
Yeah, in the run-up.
No, nothing in the run-up. And again, it was like right as I was getting airborne. Same thing, like fuel. That was a fuel flow alarm, and so I cycled that one off. And
Fuel flow.
Fuel flow.
Because
Because it's pressure and then flow, and pressure is like, was it 10-ish, and flow was like 17. And the one underneath the 17 was flashing.
What's on that box that you need? Just temperatures?
Revs.
Oh, RPMs on there? Jesus.
That's the hard one. Because first power reduction, right? That's the first thing you're looking at. After the flight, we took advantage of the fact that Justin's Tango was there. Both being powered by the 320, they should have similar cooling requirements and therefore similar cooling geometry. So we just measured the two airplanes. To see what the relative cooling air inlet and cooling air outlets were between the two airplanes. Turned out the cooling inlets on the 320 were approximately half the size of that of the Tango. So good data to have as Hakan tries to determine what his plan is going to be to deal with the cooling issue, assuming that we decide there is a cooling issue.